Hello friends, welcome to Mingle Tech. Today I'm going to discuss you what is basically the basic prediction using the supervised machine learning. And this is also a part of the internship. You can, if you continue your internship program with the Spark Foundation, then you will have this task. These are basically the six tasks over the internship that you have to complete it. That is the internship of data science and business analytics. And even you are beginner and learning a machine learning, that you can also do it and get some practice over the machine learning algorithms, right? Here our first task is the predictions. Today I'm going to basically discuss the throughout the first task. After that, another video I will discuss the second one. Okay, if you are doing the Spark Foundation internship, then if you want to look over the task or no, or something whatever you want to learn from the task, then you can continue with my video, and further on I will also bring next video so that you can get the information from that. Even if you are not pursuing that as an internship, but you want to learn the using the supervised machine learning implementation, then you can proceed with this video. Let's move. Our first task is the prediction using machine learning, right? At the that is beginner of level, right? Predict the percentage of an student based on the number of hours. This is a similar linear regression task as it's involved in two variables. You can use R, Python, SAS, Enterprise, Minor. Here is the link of the data set, and that's it. Basically, it is showing that you have to in this simple linear regression task, as you can see from here, right? Basically, there are two variables, that is one independent and the one other is dependent, right? And here is the predict the percentage of a student based on number of hours, study hours. Basically, we have to predict the percentage the student who used to study uh, according to the study hours, right? For that, we'll move to the task. Let's prediction using supervised machine learning. In this task, I try to predict the percentage of the marks that a student is expected to score before, based on the number of hours they study. This is a simple linear regression task as it involves the two variables, right? As I have said earlier. Now you can move down. Firstly, I will import some of the important libraries. That is basically from the scikit-learn, NumPy, Arras, and Pandas, Matplotlib. Let's see. First of all, I have imported the NumPy as NP, and after that, I have imported the Pandas so that I can read the dataset. And after that, I have imported the matplot.pyplot as PLT so that we can plot them in our diagrams. Basically, to visualize, we can plot, and after that, we can clearly visualize that. After that, I have imported from sklearn train test split so that I can train our data set. And after that, we have imported from sklearn dot linear model import linear regression. Basically, we are implementing the linear regression. That's why I have implemented the linear regression. Right now, it's time to importing the data set. I will give you the link of the data set in the description. You can check out from there. Firstly, I have imported the data set. After that, I have printed the starting 10 element from the top, right? Df dot head 10. If you leave it as usually, then it will basically print the 5. If I say you that if you leave now you will print then you will get the top 5 element of, but I want to visualize clearly, so that's why I printed the 10 element. You can do whatever you want. So the basically this is to visualize the data. After that, data visualization part comes, and plotting the distribution of your scores, right? There is a scatter plot, right? That describes the variation between the number of hours and the percentage. Basically, the student the x-axis denote the hours, number of hours, and the y denote the scores, that is in percentage, right? You can see from here. From the graph plotter, we can clearly see observe that there is a linear ISS. If you if you try to draw if you have to draw a line, then you can assume like that, this, right? If you assume like this, then it clearly shows that a linear y barabar mx, y equals mx line, right? After the processing, we have taken a x. After that, the data pre-processing part comes, right? We have basically taken firstly x barabar df dot ilog. Basically df is our data set, and ilog we take the indexing of the data. And here we have having the minus one from the back, that represents basically, if you look over the data, then we are having the column of 0 1 and 2. If you take 1 as column, then it represents the number of hours, and if you take minus 1, that's from the back, means it represents the score, right? If we look over the, then basically we have taken the score in our x, and in y we have taken our the number of hours. After that, we move to our training our model, right? Firstly, we have splitting the data into training and testing set, and training the algorithm. From sklearn.model selection, imported train test split, and after that, we have imported the from sklearn.linear model import linear regression. Basically, we have firstly imported the train test split to train our data set, and we have imported linear regression, that is the algorithm on which we are training our data. Right, basically I have named the model linear regression as model, right? Then after that, we have train, x test, y test, train test split, xy test size, we have taken 0.2, a random state equals 0. After that, we have fit our model, extend dot reshape. Basically reshape used to resize our data set, it does not affect the data model. And we have white. After that, we have plotting the line of regression, that is the best fit line, as I have shown here. As you can see here, as I have plotted the scatter plot of our, the difference, the percentage and number of hours. You can see here, as we draw a best fit line, then we can get a linear regression line, that is a straight line that shows the linear regression. And we have a plotted a scatter plot. Now we will move to down, making predictions. Now we have trained our algorithms, and it's time to test our model by using some predictions, right? For this, we will use our test data set. Basically, we have printing the x test our data set, and y predict model dot predict x test. If you think that from where I have taken the extras, as you have seen earlier, yeah, as you can see here, we have taken the extend x test, y test. Basically, we have trained our training data set. We have taken the training and testing data set, right? From there only. Don't get confused for that. Now we have a y predict model dot predict x test, right? And we are having the comparing actual result to the predicted result, predicted model result, right? If you compare over there, we are we have taken the actual as y test and predicted as y predicted, right? If you look over there, then we can get a, we are having if you look on the first row, then we are have actual value 20 and predicted value is 16.88. That's as you can see from the column. Now we have estimating the training and test score. If we look at the training score, in that we will get after the model dot score x train and y train after training. And if you take the test score, the model dot score x test and y test, then you can say we are having a training score of, if you take look into percentage, then it is 95.155 percentage, and if you look at test score, then it is 94.54 percentage. Now we will plot the bar graph to depict the difference between the actual and predicted value. Basically, we are having the number of hours and scores, right? You can visualize from here. I think I have taken, even I can minimize. I think this should now. You can visualize it clearly because its length I have increases. Now after visualizing the plot, now we will have our main task is to, yeah, as you can see here, our main task is what will be the predicted score if a student studies 9.25 hours a day. If a student study means 9 hours and 24 5 hours, sorry, 9 hours and 25 minutes a day, then what will be its predicted score that we have to predict, right? So that we are testing the model with our own data. That is, we have taken the hours as a 9.25, that is 9 hours and 25 minutes, and we have tested the NP. The NP is the numpy dot array hours, and we have test our test dot resave. We have basically we have received our test data. That's not the problem at all. And own predictions. Basically, I have named it as own predictions to model dot predictor x test, and we have now the number of hours, the format number of hours, and the predicted score. Score the basically this is the type of a string that we have named. The main task is here the to format own predictions. Now next the evaluating the model part comes. Now the final step is to evaluate the performance of the algorithm. This step is particularly important to compare how well the different algorithm performs on a particular data set. Here the different errors have been calculated, compare the model performance and predict the accuracy. Basically, we are if you are working on a project and you are using the different algorithm, then you have to uh, check the accuracy and the its error of the different algorithm. But right now you are working on using the single algorithm, that is linear regression. That's you are checking at once that we have the mean absolute error and root mean square error and root mean square error, right? You have checked all three, and the more importance we should give to the root mean square error because the most of the case it depends upon the root mean square error. We have seen here